To try and show you how to solve some of these tasks, because some of them we really don't have a chance to do in class. Some of them straightforward enough. Hopefully you can use your problem solving skills to figure it out. So for example, this one, if I look for the patterns, so it's forward about 9 paces to get it to the corner. After it gets to the corner, we need it to turn right, go forward twice, I believe, and turn right again, so it's pointing back in that direction. After that would be the same steps again as previously of moving forwards, except this time at the end it's going to go left, forward, forward, left. Now if we see where that gets us to, sometimes these become more challenging as they restrict the amount of code you can use. Now here's a neat trick: you can have loops within loops, and if I get that to do that once, two, I think it's 3 times, and press play, we can, and I could hit the fast mode, but I'll just let it go slow. It'll probably get to the end here and go in and finish off, and you can see that I got that one correct. In a review mode, it's quite good because it shows you how, or sorry, it shows you if you finished. I think the answers are on here somewhere too. But looking at that, that's typical code at this level. You have loops within loops, quite complex. You could solve it dragging many blocks of code, but that's a simple way to do it. Let's see, polypentagon. You guys are probably quite good at doing this in year 7, strangely. So we need 15 pentagons. The first pentagon's 50 units. So for us to draw a pentagon, it's 5 sides, and probably need to use a variable for this one, but we'll call it length of side. At the beginning, that length of side, if we go back to the variables, we need to set that equal. Need one of these blocks. Let's see. I thought we could change that. That's confusing. There we go. It's in maths. We just set it equal to 50 at the beginning. And what I need to do is use the turtle to go forward that length, which is length of side. And then hopefully you know that a pentagon is 72 degrees. It has lots already set for us. Now if we run that, we'll get 1 pentagon. And if we want to have 15 pentagons, we need to have another loop around our pentagon code. Now that, if we put it on fast, just draws the same pentagon over and over and over and over again, and that's because after the first pentagon's drawn, you want to change the length of it by 5, as it says there. So if we run that one, speed up to fast, you can see that it didn't draw enough because it didn't put 15 of them. So try that again and run that one. There we go. Mean question. Some of these it takes me some time to solve as well because I haven't used Blockly. So the mean or average of a set of numbers found by adding them all up and dividing by how many numbers are provided. Complete the function provided so it finds the mean of any given 5 positive integers. And so we get A, B, C, D, and E. Okay, on this one then we can just have a few different steps. I'm just going to make a variable called, we do have mean already, so I'll just get total to make my life a little easier. So we can set total to, and from the math functions, I'm just going to drag a bunch of these. There are other languages that would make this a lot easier to do. You can see already it's looking a little confusing, and there will be easier ways to do this, I'm sure. Into variables, so let's add A, B, C, D, and E. This is the total, and then we want to have another one which is set the mean to, again read the maths, variables, the total divided by 5. Now there are other easier ways to do that one as well. If we had lists, so we get 6.2, tells us it's correct. Now lots of the function ones are similar, so if you can practice and be a little familiar with those, it will make those a lot easier. There are lots of these types of questions where you've got images of red flowers that it wants to make look like this. So they're all quite similar of what you need to do. So here's what the image looks like. And they've got a special piece of code that lets you loop for every pixel, and you can change what they are. But we need to use some logic here, because I believe it says select the pixels where the red component is greater than the average of the blue and green values. That's quite difficult. For the selected pixels, set the value of the blue component to red pixels. For the selected pixels, set the value of the red pixels to 0. Right, this is very difficult. Greater than the average. Oh my goodness. So we need to do definitely want to have. Let's see if we've got any functions you can use here. Logic. Ooh. No variables. So how are we going to do this one? Well, for being pixels, I want to do if we can build this up a little bit at a time. Get x coordinate, get index, get one, set. Ooh, this is tricky. If we need to get the values first. So we want to get average of green and values. So we want to do get the green, and from the average we want to get the blue, and we want to do that. Oh my goodness, this is a tricky one. We want to do that. Wrong one. We want to still math. That one. We want to do that value divided by 2. And I want to check if the red value of P is greater than this one. So that's checking if it's greater than the average. We want to set the pixel value to component. See if we've got a different one there. Set R. So, okay, so we want to set the value of the blue component. So that's blue. So set blue value there. No, try that again. So we want to set the blue value. I'm just going to throw it in the trash. Set the blue value to the red value, and we want to set the pixels. Select the pixels, set the value of the red pixels to 0. So to set the red pixels to 0. So this one, these are very tricky. Took a lot of thinking for me to get this one, but they're normally the same. If you struggle with it, I would just not waste time on it. These are very complex, and even it had me thinking how to solve it. So that one there, it checks if the red value of the current pixel is greater than the average of the green and the blue pixels. And if it is, it sets the blue value to whichever the red one was, and it sets the red value to 0. So basically it turns off the red colour of the original image. Pac-Man, there's quite a lot of tasks like this come up that are not too difficult. So we want to have first shape being, always name these. So number of sides for a circle, there's 1. The colour of it is that, I think it's that orangey colour. The radius is 20, and if you look at the position, it's 50x, 50y. So 50, 50. And if we run that, we'll see it there. Now, after we've got that shape, we need another shape, which is the triangle for the mouth, and the radius of that is 20. radius 20, color is white for the background. If we run that, we'll see, well, we don't see it at all because the position of the X and Y is not correct. So let's try 50, 50 for that one, and we can see it's there. So radius 20, 3 sides color. So we need to figure out where we want to get it. So position X is obviously further to the right, so let's try 70. And sometimes trial and error works for these. We want it to be not so down. So you can see the coordinate for that one looks as if it's right in the middle. So let's try 30. So too high, so let's try 50. Too low, let's try 40. You can see that's almost right. Let's see what else can we change here. 60. Too far back. 65. Just a little bit of trial and error. I think 70 is correct on that one. Needs to be lower down, so we want it to be 50. Let's try. Too low. 45. I think I need to clear this because I can't see. I'm going to come back to see the triangular shape. Is there a rotate option? I missed this part out entirely. Okay, so let's try again. So it's circle. I had the right code, except I didn't realise we can rotate it. So 20, we want to get the middle being 50 and 50. And then we want to add another shape, which is going to be the mouth. So the centre of that, and then I want to rotate it. Let's try again. Let's call this shape mouth. Number of sides 3, the colour is white, radius 20, position 2020, so let's do that. We obviously can't see it. Let's just make it black for now so we can see where it is. And what we're going to do is shape name me, which is the mouth, dot set angle, rotate 45 degrees. Let's try rotating 90 instead. That one's not going to work. Let's try 180. Not going to work. 270 is correct. So we want it to be 270, and then we need to get the X and Y coordinates correct. So it's probably going to be 50 on the Y, and then we want to jump across. I think it was 70. Was about correct. And now, if we change the colour to white, we can see that it changes. Now that looks correct to me. White triangle, everything's multiples of 10. Maybe it needs to be slightly further out. Nope. Let's try. It can't be 75 because it's multiples of 10. 70. I think that looks correct. I'll check again later to see why that's not working. This one here, different type of Pac-Man. Maybe if you did the year 7 tasks with us, you would be able to do this one because this is how the sun worked. Now what we want to do is get to go, let's just look at forward 20 first of all to see if it's far enough. So maybe we want forward 150, see how far it goes. So forward 150 is correct. Before we start, I'm going to get it to rotate 45 degrees before moving forwards. Oops, before moving forwards. Delete that one. So you can see when we do that, it draws the first. Try and throw that in the trash. It will draw that first line. Now what it needs to do is, and if you look at the angle there, there's 45 degrees either side, so there's 90 degrees missing. So 360 minus the 90, hopefully we know, is 270 times we want to draw that particular line. But before we do it, we need it to move backwards the same angle, and then we need it to turn left by 1 degree. So it will draw lots and lots of little lines. Now the reason that's not working is because I meant to change that to move backwards. So if we fix that, we can see that reason we're getting this crazy pattern is because I wanted to turn right before the loop, not every time in the loop. So you can see even I can make mistakes as well. You can see it's just moving forward, back, forward, back, forward, back, really, 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 really fast. And if you do that 270 times, you get the Pac-Man. Now that is correct. You can see, same as the last time, it's